Hello students, welcome to Edubbey Global Solution. Again in our mathematics class, we're going to be looking at another subtopic on the similarity and congruency, which is congruent triangles. Under this, we're going to be looking at some conditions that certify congruent triangles. We're going to be looking at class activities and as well as past questions. We have our interactive content here that will serve as a guide for this class. Okay, so let's start. Congruent triangle. For congruent shapes, like we have said in the other class, that all corresponding sides must have the same length and all corresponding angle must also be what? Must also be the same. Now, so if you want to decide whether two triangles are congruent, it's not compulsory that all the lengths and all the angles must be stated. Okay, so there are some conditions that must be satisfied for a triangle or two triangles to be what? To be congruent in nature. So now let's look at some of those conditions. But before we go there, let's look at these activities here. We said all corresponding sides of a congruent triangle has the same length and corresponding angles have the same size. That is very true. We made mention of that before now. Okay. Now, when we're talking about some of the conditions that must be satisfied for a congruent triangle to take place, we have the very first one here that we call SSS, which is side. When two triangles have corresponding sides that are the same length, then their triangles are congruent. Now let's look at these triangles that we have here. Let's look at these two triangles. If you look at this one, angle AB here is the same thing as angle FE. This side AB rather is the same thing as side FE. Side BC is the same thing as side DF, and side AC is the same thing as side DE. So this type of triangle satisfy a congruent triangle. Okay, now let's see the next condition, which is SAS, which is side angle side. Okay, now what happens for a triangle to be side angle side and to be congruent in nature? So when two triangles have two corresponding sides of the same length and the angle between them is also of the same size, then the triangle is said to be congruent. So if you have two triangles and their sides are of the same length, so they have the same length, let's assume that the first is 6 centimeter, the other length as well also is 6 centimeter, and the angle that is between them is also the same. That is, if you have 60 degrees in one of the side, then you have 60 degrees in the other side. They will say that type of triangles is what? They are congruent in nature. Okay, so now let's certify our class activities by putting in the right answer in our boxes. This will be for the same length, and we have this to be the same size. Okay, now let's check. Now let's look at the picture that we have here. Look at it. XY is the same thing as what? Is the same thing as PQ. ZR is the same thing as what? RQ here. And XZ is the same thing as RP here. And if you look at it, we have an angle here which is angle P. So whatever it is in angle P will also be angle X. So we said that these two triangles are congruent in nature. Now let's look at another condition. We call this ASA, that is angle side angle. So if when two triangles have a pair of corresponding angle, okay, of the same size, okay, the length of the sides between the two angles is also the same length, then the triangle will be congruent in nature. So when we have two corresponding angles that have the same size, okay, and we have their length to be the same length, then we say that type of angle is actually congruent in nature. Now let's fix in our right answers to the boxes here. So we have corresponding angles, okay. So they must be of what? They must be of the same size, okay, and they must their length must be of the same length. So now let's look at what we have here. LN is the same thing as JH. If you look at it, LM is also the same thing as HI. That is the size you are looking here, and MN is also the same thing as size JI. So now if you look at it, we have an angle here, angle M, and we have an angle I. So this type of whatever that, assuming we have 60 degree on angle Y, then we're going to be having the same thing on angle M. Okay, now let's look at another condition that we have here. Okay, now the condition says that when two triangles have a pair of corresponding angles of the same size, okay, the length of the other corresponding sides is the same length, then we say that the triangle are congruent in nature. So if you have two if you have two triangles and we have their angles to be the same size, okay, so the length of one of the corresponding sides must also be what? Must also be the same. So that implies that that type of triangle is what is congruent in nature. So we call that condition angle size condition. So that implies that we must have a corresponding angle that have the same what? That have the same length. Okay. So if they have the same length, the corresponding size also will have the same length. Then we say that that type of triangle is what is congruent in nature. Now let's look at this. If you look at what we have here, side SU is the same thing as side VX. Side UT is the same thing as what? Side WS, and side ST is the same thing as side WV. And whatever that we have here, which is angle T, will also be what we have in angle W. Okay, now let's look at the next condition we have here, which is what? Right angle hypotenuse side. We call that RHS. Okay, in a right angle triangle, the hypotenuse and one other side of the triangle are equal to the hypotenuse and the corresponding of the other triangle. Then we say that that type of triangle will be congruent. So if the hypotenuse and one other side of a triangle is equal to the hypotenuse and the corresponding sides of the other triangle, then we say that that type of right angle triangle is what is congruent in nature. So we have the hypotenuse of one side of a triangle to be equal to the hypotenuse of the other sides of that of a triangle. Now we say that that type of triangle is in congruent in nature. Now let's look at it. We see we have BA, that side BA is the same thing as side DF here. Side DE here will be the same thing as side AC, and side BC, which is hypotenuse, will be the same thing as side FE. So we say that the right angle triangle ABC is equal to right angle triangle DEF. Now, let's look at some of the activities that we have here. We have these two triangles here. We have to justify our answer whether the two triangles below are definitely congruent. Now, if you look at that triangle, you will see that they have actually almost all sides of the triangle to be what? To be equal. So that is what we have SSS, and that is all the sides. If you look at this here, we have 4 centimeter here, and the other triangle also is giving us 4 centimeter. If you look at this, we have 5 centimeter here, and the other triangle is giving us 5 centimeter. If you look at this, we have 3.5 centimeter here, and the other side is also giving us 3.5 centimeter. So we can say that these two triangles satisfy the condition for a congruent triangle. Now let's look at another activities here. We have to justify if these two activities are congruent in nature. If you look at this here, you see that we have two sides, or we have the same two sides that are the same, and we have an angle here that has actually the same. So this one satisfies SAS, that is side angle side. So we have two sides equal with an angle also equal. So we can say that these two triangles that we have here is also congruent in nature. Now let's look at the first question that we have here. We have this angle where you look at it, this is a triangle, but it's actually being divided into two right angles, which is angle AGB and angle AGC. That is a right angle triangle of different. But if you look at it generally, we have a triangle ABC. So in this triangle, we said that angle AC is equal to angle BD. Okay, now we are now using that and we have a perpendicular line. We treated that in the previous class. If you look at the perpendicular line that we have here, AD is actually perpendicular to what? To BC. Okay, now if you have that, then we can now say that yes, if it actually it is actually a congruent triangle in the sense that we have a two triangle here now, which is angle ACD and our triangle ABD. Now let's look at that. If they said that we should confirm if it is congruent in nature, remember we look at the condition, which is what? Right angle hypotenuse side. That's the condition for congruent triangle. So if angle ACD is equal to angle ABD, then we say that what? It is actually congruent in nature. And remember, a right angle triangle is what? Is 90 degrees. So we have angle ADC to be equal to what? Angle ABC. And remember, angle ADC will give us 90 degrees. Angle ABD also will give us what? It will give us 90 degrees. Now, if we look at this triangle, we have we have a side there that link up to make what? A triangle, which is what? AD. So AD here join AB to give us a right angle triangle, and join AC to give us a right angle triangle. So we are saying that side AD is common to both triangles. So having that, what type of condition is this? If you look at this, we have a right angle triangle in the triangle. So the condition is what? Is a right angle hypotenuse side condition. This takes us to the end of our class. We want you to subscribe to our channel www.edubbey.com for the full interactive content of this class. Thank you.